Hello everyone, welcome to another video. Today we are going to learn about how much energy is released after burning. Any compound, anything, whatever we burn, we get some energy. So today we are going to study how much energy is released after burning, or in other words we can say how much energy is released when it is burned in oxygen or air, or alternatively we can say this is as a combustion reaction, the heat of combustion. Here you can see a reaction, carbon and oxygen reacting together, which means carbon is burning in oxygen to form carbon dioxide, and at the same time it is releasing some energy around minus 94.3 kilocalorie. On the other way, when carbon is burned in half mole of oxygen, it produces carbon monoxide and the change in enthalpy or heat is around minus 26.0 kilocalorie. So from these two reactions, later we will discuss which one will be considered as heat of combustion and which one is not. So let us move to the topic. How much energy is released after burning or heat of combustion? The change in enthalpy of a system when 1 mole of substance is completely burnt in excess of air or oxygen is known as heat of combustion, or the energy released during or after burning. So this is symbolized as delta AC. Delta AC, that means delta means change in, and H means enthalpy or heat, and C represents the combustion. That means the delta AC represents the change in enthalpy during combustion or heat of combustion. As for example, heat of combustion of methane is around minus 21.0 kilocalorie or 87.78 kilojoule as shown by the equation. Here you can see the equation. When 1 mole of methane gas is burned into 2 mole of oxygen, it produces carbon dioxide gas and 2 moles of water, and the heat of combustion is equal to 21.0 kilocalorie. Now, as already I have mentioned, these two reactions, when 1 mole of carbon is burned into 1 mole of oxygen, it produces carbon dioxide, while it releases 94.3 kilocalorie. But when 1 mole of carbon and half mole of oxygen reacts, or when 1 mole of carbon is burned in half mole of oxygen, it is incomplete combustion because it produces carbon monoxide and the change in energy is around minus 26.0 kilocalorie. How we can say this is an incomplete combustion? Because carbon monoxide can be further oxidized to produce carbon dioxide, and from our definition of heat of combustion, we need to burn something in sufficient oxygen. That means as much as oxygen we need. So the energy released when 1 mole of substance is burnt into sufficient oxygen. So for this reaction this is not sufficient, because here we can see it needs at least 1 mole of oxygen to burn 1 mole of carbon. So here we are using only half mole of oxygen. Therefore it needs more oxygen to burn 1 mole of carbon completely. So this reaction will not be considered as this is also a combustion reaction, but we cannot mention this as a heat of combustion. For this is minus 26.0 kilocalorie cannot be the heat of combustion of carbon, while carbon, that means minus 94.3 kilocalorie, will be the heat of combustion of carbon. It should be noted clearly that heat of combustion of a substance is always negative. Why? because most of the reaction with oxygen, that means when something is burned, we always get some energy which represents the energy is released. Therefore, we always consider this is an exothermic reaction and the enthalpy change is negative. Now we are going to learn about the applications of heat of combustion, or why we are learning these types of reactions. There are several applications, however, I am going to mention only two. Just here, first one, the calculation of heat of formation. When we know the heat of combustion, ultimately we can get the heat of formation, or we can get calculated the heat of formation. How? In next slide, or in today's last slide, I will show how we can get the heat of formation of a compound named propane. So let's move from here. Since the heats of combustion of organic compounds can be determined considerable case, these are employed to calculate their heats of formation. The direct determination of this is often impossible because heat of formation is always little bit difficult. So if we know the heat of combustion of several compounds, then in alternate way we can get the heat of formation for any compound. Another very interesting thing, for every different types of food package or pack, you will see something, there some energy value is mentioned. That means how much energy you will get when you eat a specific amount, like as 100 milligram or 100 gram or 100 like this by this amount. So 1 gram or 100 gram, how much energy you will gain. That means if you will become fat or not. So every food package or food pack give the energy how much you will gain when you eat or you drink 1 gram or 100 gram of that substance or that food. So how we determine this? Let us consider for a gram of chips. When you eat chips, you get some energy. So in each pack of chip, you will get the value for energy. Then how it is obtained? The chips are burned into oxygen and measure the amount of heat released or energy released, and then the value is given into the food pack, like as how much energy is released or how much energy you will gain when you eat this amount of food. So this is the alternate way how we can get the calorific value of foods and fuels, not only foods, for every fuels. Now we are going to learn about one of the very interesting thing. We know methane and ethane are two different fuels, but do you know which fuel will be efficient? If we compare, which one will be more efficient? Here you can see methane has the molecular weight carbon 12 and hydrogen 4, then 12 plus 4 16, and ethane has molecular weight 2 carbon and 6 hydrogen, that means 2 carbon 12 into 2 and 6, that means 30. So let us see how much energy is released when 1 mole of methane and 1 mole of ethane is burned into sufficient oxygen. Here you can see when 1 mole of methane is burned, it gives around 890.3 kilojoule, and when 1 mole of ethane is burned, it gives around 1559.7 kilojoule. But you may get some impression or idea that ethane is better fuel, ethane as a better fuel, but is it real? then we have to calculate how much energy we are getting from 1 gram of fuel. So from 16 gram of methane we are getting this, then how much we are getting from 1 gram of methane? Just here you can see 55.64 kilojoule, and from ethane for 1 gram we are getting 51.90 kilojoule. Therefore we can say easily that methane will be better fuel, because the fuel value or burning 1 gram of methane we are getting more energy compared to burning 1 gram of ethane. Thus methane has better fuel efficiency than ethane. Now we are going to have the mathematical problem, how we can estimate the heat of formation from heat of combustion. Here you can see the problem, calculate the standard heat of formation of propane. That means we have to find out the heat of formation, as already we have mentioned in the previous slide, that we can use heat of combustion to calculate or to estimate the heat of formation of any compound. So here you have to find out the heat of formation of ethane. If its heat of combustion is this much, 222.0.2 kilojoule per mole, the heats of formation of carbon dioxide, water, liquid water are this much value. So we can write down these types of equation. Already mentioned the heat of combustion of propane is, that means when 1 mole of propane reacts with 5 mole of oxygen, it produces carbon dioxide and water, and the energy change or heat of combustion is 22220.2 kilojoule per mole. Again heat of combustion of carbon or heats of formation of carbon dioxide is given, carbon plus oxygen, it produces carbon dioxide, and delta is equal minus 393.5 kilojoule. Again the heat of formation of water liquid or liquid water is given, minus 285.8 kilojoule. So now how we can find out the heat of formation of propane? Just we need to find out a way where we can write down the equation like this: 3 carbon plus 4 hydrogen molecule or 4 moles of hydrogen to produce C3H8, because in propane we need 8 hydrogen atoms and 3 carbon atoms. Therefore we can write down these types of equation. So we need to manipulate these couple of or these 3 equations so that we can get these types of reaction, but by anyhow. Here in the equation number 2 we have only 1 carbon. So if we multiply with 3 this equation number 2, then we can get 3 carbon and then multiply with oxygen, then oxygen, that means we multiply equation number 2 with 3, so 3 carbon 3 O2 molecule, and then we are getting 3 carbon dioxide, and then delta is will also be multiplied by 3. Okay, then here we are getting 3 carbon plus 3 oxygen and 3 carbon dioxide, and delta is multiplied by 3, 393.5. then we need another part, 4 hydrogen. So here we have only 1 mole of hydrogen. So if we multiply equation number 3 with 4, then we can get 4 moles of hydrogen, which corresponds to 8 hydrogen atoms. So if we multiply equation number 3 with 4, then we will get this equation. This energy corresponds to the energy 4 multiplied by this. So subtracting equation 1 from equation 4, so here is the equation number 4, you can see. So we are going to get this equation and this equation. After summation of this equation and this equation, we are going to get equation number 4. Now if we subtract this equation, if we subtract equation number 1 from equation number 4, then what will be eliminated? Here we have 5 moles of oxygen. 5 moles of oxygen will be eliminated, and C3H8 will be our product, because we are going to get a minus in this portion. So we are going to subtract equation number 1 from this equation, and then we will get this. So 3 carbon plus 4 hydrogen, that means 3 moles of carbon and 3 hydrogen gas, plus 5 oxygen minus 5 oxygen is here we should also get minus 3 C3H8, that means we are getting plus C3H8, which corresponds to this oxygen will be eliminated. 3 carbon plus 4 hydrogen will give the C3H8, and the energy will be this. So from here we know the heat of combustion of carbon, heat of combustion of hydrogen, heat of combustion of propane, and ultimately we could find out the heat of formation of propane, which is minus 103.5 kilojoule per mole. Therefore, as already I have mentioned in the previous slides, that we can calculate the heat of formation of a compound by knowing the heat of combustion. So this is the end of today's class, and if you have any questions and comments, you can ask me in comment box. And also thank you very much for watching